In this video, we're going to be taking a look at some dosage calculations. It's going to be a basic review for Nursing 220 at Purdue University for the spring 2023 semester. This video is going to basically have 3 lesson objectives. The first one is students will be able to do metric conversions using a mnemonic device for the metric prefixes. You'll end up doing a lot of conversions within the metric system for your dosage calculation problems, so it helps to have a mnemonic device that will help you do those conversions. Second lesson objective, students will be able to use unit analysis to help solve dosage calculation problems. It's a pretty straightforward process, this unit analysis, pretty easy, straightforward, and it can be used for all of your dosage calculation problems. Third lesson objective, students will understand the difference between per day and per dose. So the very last example that we go through and work out, we'll calculate what the per dose is and then compare that answer to a per day dosage. So 3 pretty straightforward lesson objectives for this short review. We're going to start with the metric conversions. All right, these 2 examples are just going to be straight how to convert in the metric system. All right, to be able to convert within the metric system, it helps to be able to take the metric prefixes and write them from largest to smallest. So kilo, hecto, deca, base unit, which is going to be our liters, our grams, and our meters, deci, centa, milli. All right, if you can remember this chart from largest to smallest, then it's real easy to convert in the metric system. To do that, we're going to use a mnemonic device. We're going to take the first letter in each one of these and put a cute little saying to it. Kittens hate dogs because dogs can't meow. That will help you to be able to then write the metric prefixes from largest to smallest. The reason we are doing this left to right, if I hop my decimal to the left in the chart, I'm going to move my decimal and the number to the left. If I hop to the right in this chart, then I will move the decimal to the right. All right, so for the first example here, we've got 530 milliliters, and we're going to convert it to liters. All right, liters is the base unit. All right, so my base unit is right here. Milliliters, prefix milli, is right here. So I'm going from milliliters to my base unit. So that's going to involve 1, 2, 3 hops to the left. So if I hop 3 hops to the left in the chart, I'm going to move my decimal 3 hops to the left. I'm going to take that 530, all right, the number 530 milliliters has a decimal point that is at the far right-hand side. So I'm going to move 3 hops to the left. I'm going to go around the 0. There's 1, 2, 3. That puts my decimal at the front of this number. So we're going to write 0.53. We're going to drop off that extra 0 because it's not needed. And I was converting from milliliters to liters, so that makes this liters. So 0.53 liters, just a straight conversion within the metric system. All right, for a second example here, we're going to convert 0.8 kilograms to grams. Again, taking a look at this, grams is our base unit, so our base unit is right here. Kilogram, prefix kilo, is right here. So I'm going from kilograms to my base unit. So I'm going to count my hops. It's going to be 1, 2, 3 hops to the right. If I move 3 hops to the right in the chart, I'm going to move my decimal 3 places to the right. So I'm going to write that 0.8, and then I'm going to hop that decimal 3 places to the right. I'm going to go around the 8 initially, so there's my first hop, second hop, third hop. I have to add some imaginary zeros. It puts the decimal now at the end of that number. All right, just looking at that straight, that's just going to be the number 800. All right, I was going from kilograms to grams, so that's 800 grams. All right, so those 2 examples, just straightforward conversions within the metric system. In this example, we'll actually use the metric conversion chart in an actual nursing question. A nurse is preparing to administer vancomycin 5 milligrams IV daily to an adult patient. The recommended dose is 500 milligrams to 3,000 milligrams daily. Is the ordered dose safe. All right, now, obviously, we've got to do some comparing here. I've got milligrams, and the order is in 5 grams. So I can't just look at these to see if it's going to be a safe dose. So the shortest and quickest way to do this is to focus on that 5 grams and convert it to milligrams. This 5 grams is going to be the base unit. So that means I'm going to be starting at my base unit here and converting to milligrams, so the prefix milli. So that's going to be 1, 2, 3 hops to the right. So I'm going to take the 5 grams. All right, that decimal point there is at the end. I'm going to go 3 hops to the right. 1, 2, 3. That means I'm going to have to add 3 imaginary zeros. That's going to make that 5,000 milligrams. Okay, I started the base unit, went to milligrams. Now I'm going to take that number and then I'm going to see, okay, is it in that range? And clearly we can see that it does not fall in the recommended dose. So to answer the question, is the ordered dose safe? The answer is no. Transition to another type of problem that you might encounter here. And this one, we're going to start using our unit analysis. Okay, now you don't have to use unit analysis on this because some of you are going to probably be able to read this question and then just be able to know what you're supposed to do. But for anyone that does not, unit analysis, like I had said earlier, will be able to be used for every one of your problems. All right, the example here says your patient weighs 99 pounds. How many kilograms does your patient weigh? So this is just straight, we're converting. Now, we are not converting within the same system. This is 99 pounds. This is kilograms, what I want to go to. That is not the same system. This is the metric system. This is our US system. All right, so our chart is not going to work. That chart that I just showed you is only when converting within the metric system. So you do have to have memorized your conversion rates here. So 1 kilogram is equal to 2.2 pounds. All right, that's just something you have to have memorized. Now, some of you are going to look at this and go, okay, well, if it's 99 pounds, all right, and I know 1 kilogram is 2.2 pounds, then you're going to automatically know, oh, I've got to take 99 divided by 2.2. Now, for those of you that do not see that as easily, let's use unit analysis and do an introduction actually of what unit analysis is. All right, I'm given 99 pounds. So my unit analysis is going to involve a bunch of rates with multiplication. All right, that's a whole number, so I'm going to choose to write it as 99 pounds over 1 just so I have a fraction because all of this is going to be based on fractions. Okay, now I'm going to multiply this times my conversion here of what's equivalent. 1 kilogram is equal to 2.2 pounds. Now, just like you multiplied fractions in middle school and you crossed out numbers top and bottom, we're going to cross out labels. All right, I've got pounds in the top here. In this conversion right here, I've got pounds and I've got kilograms. I'm going to choose to write the 2.2 pounds in the denominator so that I will have one label on the top, one label on the bottom, and they're going to be able to cross off. So I'm going to write 1 kilogram over 2.2 pounds. All right, so you have to make that choice. I'm making that choice because I want my pounds to go away. I want to be left with just kilograms. So I choose to put the 2.2 pounds in the bottom, the 1 kilogram on the top. That gives me pounds in the top and a pounds in the bottom, which I can cross off. All right, when you do this unit analysis, then once you get everything crossed off, you can multiply 2, 3, 4, 5 of these different fractions, depending on what you're trying to convert to. The only label that you should have left should be the label of what you want your answer to be. All right, this question said how many kilograms. All right, well, kilograms is the only label I have. Okay, so I'm going to multiply straight across the top. 99 times 1, 99, and I've got a label of kilograms. 1 times 2.2, all right, no label on the bottom. I'm going to take a calculator. I'm going to take 99 divided by 2.2, and then that's going to give me 45 with my only label there of kilograms. All right, now, would you have to have had to have done unit analysis on that? No, not necessarily. All right, for those of you that can just look at this and realize, oh, 99 divided by 2.2 is going to get you kilograms, that's fine. All right, but this is a nice little introduction into what unit analysis is. Okay, now let's step it up and go to another example here. All right. A nurse is going to administer midazolam 0.07 milligrams per kilogram IM to a patient who weighs 50 kilograms. The medicine is available as midazolam 5 milligrams per milliliter. How many milliliters should the nurse administer? Okay. The IM, intermuscular, all right, so there are things that in your nursing abbreviations that you're going to have memorized. I highlighted this in the question, but it's asking for milliliters. So if I'm going to do a unit analysis, all of my labels have to cross out, and I need to be left with milliliters when I get done. All right, now, probably the easiest way to do this is to start with whatever is ordered. All right, so the order was 0.07 milligrams per kilograms. So that's what I'm going to write down first. I'm going to go 0.07 milligrams over kilograms. All right, and then let's above that write ordered, because this is what was ordered. All right, now I'm going to use my unit analysis. So then I'm going to multiply this by a rate that I know. All right, well, it's available as 5 milligrams per milliliter. All right, so I'm going to multiply it by what is available. So let's go ahead and write available up here. And then we have to make a decision about how we're going to write that fraction. Okay, so it's 5 milligrams per milliliter. Milligrams is in the top right here. I want milligrams to cross out. So when I choose to write this, I'm going to put the 5 milligrams on the bottom and the milliliters on the top. All right, that's going to let me cross out my labels of milligram and milligram. All right, now, this is how you know you're not done yet. All right, I have milliliters left as a label in the top. I have kilograms left as a label in the bottom. But they didn't ask me for milliliters per kilogram. They want to know how many milliliters. That's the only label I'm allowed to have left. For me to be able to cross out kilograms, I am going to have to consider how much the person weighs. Okay, so I'm going to multiply this by the person's weight. So let's label this as weight right there. It's 50 kilograms. Now, kilograms is in the bottom here. If I write 50 kilograms over 1, it's going to put the kilograms in the top. All right, that then is going to allow me to take kilograms and kilograms being in opposite locations and cross them out. So here's kilograms, I can cross them out. Now if I look, the only label that I have left anywhere is milliliters. That's what the question asked for. How many milliliters should the nurse administer? All right, so then you're just going to use a calculator. You're going to go 0.07 times 50. All right, across the top, that's going to give me a 3.5 ml. All right, across the bottom, 1 times 5, I have a 5 there. Okay, then you're going to divide 3.5 divided by 5. That will leave you then with 0.7 milliliters. Okay, so this is definitely one where you are going to have to consider the weight. All right, if you don't remember that, like a lot of your problems are going to be, you're going to take what's ordered, you're going to multiply it by what's available, and that's all you're going to have to do. All right, however, once you do that, stop and look at your labels. If your labels don't match what the question is asking for, then that means you're going to have to multiply by another conversion factor. All right, in this case, it was necessary to involve the person's weight. Okay, now let's go ahead and take a look at another question here. This will be our last example, and we'll do this in like a 3-parter. All right, a nurse is caring for a patient who weighs 110 pounds. The doctor ordered ranitidine, 75 milligrams, POBID, by mouth twice a day. So there's, again, some abbreviations you're going to have to know. The medicine is available as ranitidine, 150 milligrams per 5 milliliters. Okay, so all the information that we need. So for our part A, we're going to do 3 parts to this. How many milliliters will be given per dose? All right, how many milliliters will be given per dose? All right, so again, we're going to go with that same pattern. We're going to take what was ordered and multiply that by what is available. Okay, so what was ordered was the 75 milligrams. Okay, so I'm going to go 75 milligrams over 1. I'm going to go ahead and label that as ordered. Okay, I want to multiply that by whatever I have that is available. All right, the medicine is available as 150 milligrams per 5 milliliters. Okay, so how am I going to line this up? I want to make labels cross out. All right, it's available. I've got milligrams and milliliters. My first one has milligrams. So the only part that matches is the milligrams. I need the milligrams then on the bottom so it will cross out. So I'm going to write the 150 milligrams on the bottom. I'm going to write the 5 milliliters on the top. All right, that's going to allow me to cross out milligrams and milligrams. Take a look at everything that's left. The only label that's left is mLs. That's what the question asked for. How many milliliters will be given per dose? All right, so it now is a straight multiply across the top, multiply across the bottom. 75 times 5 will be 375 milliliters on top. 150 times 1 is 150. There on the bottom, straight divide here, 375 divided by 150 is going to give me 2.5, and this is milliliters, all right, per dose. Okay, so every time I give it, 2.5 milliliters per dose. All right, now let's take a look at this. How many total milliliters will be given per day? All right, now for that, this is where you have to have this BID memorized. All right, you've got to know what that abbreviation is. That abbreviation is twice a day, 2 times a day. So then that means I'm going to take 2.5 times 2, and that's going to give me 5 milliliters per day. All right, so BID twice per day. All right, now we're ready to take a look at part C. Restated the question up here at the top, and we're going to take a look at our part C. The recommended safe dose for ranitidine is 1.5 milligrams per kilogram to 3 milligrams per kilogram, POBID, is the ordered dosage within the safe range for this patient. All right, now the thing is, we're going to come up here and we're going to look at what they gave us for the patient's weight. It's 110 pounds. All right, the recommended safe dose is in kilograms. So before I can even figure out whether or not it is a safe dose, I'm going to have to convert that 110 pounds to kilograms. And again, some of you are just going to realize that you're supposed to take 110 divided by 2.2, and that's going to give you your kilograms. But for those that do not see that easily, we can use the unit analysis. So we can say 110 pounds over 1. We'll multiply it by our rate that we have memorized here, that 1 kilogram is 2.2 pounds. We're going to choose to put the pounds on the bottom. So 2.2 pounds and 1 kilogram. Okay, that's going to show us that, yes, division really is what is needed here. Our pounds are going to cross off, so we'll have 110 kilograms on the top multiplying across the bottom, we'll have that 2.2. So that does show us to take the 110 divided by 2.2. That's going to give us 50 kilograms. All right, so the patient weighs 50 kilograms. Okay, now what we're going to do is we have got to see if this is it's going to fall in here. So what we're going to do, I'm just going to do two conversions here, two different unit analysis. I'm going to do a unit analysis on the lower end of the range. I'm going to do a unit analysis on the higher end of the range, and then see if the prescribed dose, which was the 75 milligrams, falls in that range. Okay, so let's do our lower range first. All right, again, I'm going to use the unit analysis. So my lower range here is the 1.5 milligrams per kilogram. All right, and then I'm going to include the person's weight, which was 50 kilograms. I want those kilograms to cross out. I'll be left with just milligrams, and that's what the order was for. It was in milligrams. So I'm going to multiply this by the 50 kilograms, the patient's weight, over 1. That's going to let me cross out kilograms and kilograms there. So multiply straight across the top, multiply straight across the bottom. I'm just going to get a 1.5 times 50, which is going to be a 75 milligrams. All right, now I'm going to go ahead and I'm going to do the higher end of my range. So my higher range. All right, just to be safe, to make sure this is going to fall in here, I'm going to take my 3 milligrams per kilogram. So 3 milligrams per kilogram. Again, I want to consider the patient's weight. I'm going to multiply it by the 50 kilograms so that my kilograms cross out. So 50 kilograms over 1. I've got kilograms on the bottom, kilograms on the top. That's going to cross out. I'm going to multiply straight across the top. 3 times 50 is going to be 150. The only label there is milligrams. So my range is between 75 milligrams and 150 milligrams is the safe dosage. All right, and what was ordered was the 75 milligrams. It is within this range. So then the answer to the question is yes. Is the ordered dosage within the safe range for the patient? Yes, it is. Okay, so just to wrap up there with a part C, we've kind of covered everything. We've taken a look at the metric prefixes with a mnemonic device to help you convert within the metric system. We have done an example with our per dose and per day, trying to emphasize that. And then we've also done several examples where we have used this unit analysis. Number one thing to remember about unit analysis is the fact that your labels, you choose how to line up your different conversion factors so that labels in the opposite locations cross out. You know you're done when the only label left in the problem is what the question is asking for. All right, so definitely thanks for watching. If the videos are helping, in general, I generally say if the videos are helping, check the channel out for more videos. I do plan on continuing to do more nursing videos. I think this is a really good practical application of math and very, very much needed for those nursing students out there. So hopefully the video helped, and you're going to be good at those dosage calculations. Thanks so much for watching.